Researchers in the Kalahari Desert have documented a biological anomaly unfolding in real time. Since the 1990s, on days where the temperature exceeds 35 degrees Celsius, 3-month-old baby meerkats show a steady decrease in overall body mass. Data shows the adults are catching the same volume of food as they always have. Despite this consistent food supply, the pups are losing mass, signaling a physical reaction to the changing environment rather than simple starvation. This weight loss is a visible indicator of the biological pressure extreme heat places on mammals. For many of the 900,000 species currently facing extinction, the primary threat is the speed of this change. Large mammals with long reproductive cycles lack the generational time required to evolve physical countermeasures as their habitats overheat. To understand the physical toll of this transition, we have to look 56 million years into the past, to the last time the Earth's thermostat was pushed to its absolute limit. During the Paleocene-Eocene thermal maximum, or PETM, massive volcanic eruptions flooded the atmosphere with greenhouse gases. Global temperatures skyrocketed by 5 degrees Celsius. This ancient hothouse period serves as a historical reference for our current climate trajectory, showing the inevitable biological end state for mammals living on a rapidly warming planet. The Bighorn Basin in Wyoming contains a dense fossil record of life during the PETM. For decades, paleontologists have searched these rocky slopes for evidence of how ancient mammals managed to survive the heat. Fossilized jawbones recovered from these layers show a consistent trend. As the planet warmed, the mammal shrank. During the 200,000-year peak of the PETM, mammalian body size decreased by roughly 20%. Fascinated, the scale of this downsizing changed the face of the ecosystem. Early horses and large ergosaurs like the Coryphodon underwent a massive reduction, with some species shrinking from the size of a beagle to the size of a chihuahua. Temperature alone didn't cause this change. The shrinking was a biological response to a shift in the chemistry of the air they breathed and the plants they consumed. High concentrations of carbon dioxide create a botanical paradox. While the gas acts as a fertilizer and makes plants grow faster, it simultaneously reduces their nutritional value. In this high CO2 environment, plants absorb excess carbon but retain significantly less nitrogen. Because nitrogen is the core building block for animal protein and DNA, the vegetation becomes a form of nutritional junk food. We can see the evidence of this nutritional collapse in PETM fossils. Many leaves are riddled with feeding holes because insects had to consume much larger quantities of plant matter just to meet their basic nitrogen requirements. This created a domino effect throughout the food web. With the base of the food chain stripped of nutrients, mammalian bodies were forced to downsize, evolving smaller frames that could survive on a lower quality diet. This chart tracks the 5-degree warming of the PETM. It took 10,000 years to reach that temperature. Today, human activity releases carbon much faster. We are on track to reach those same PETM conditions in just 200 years. The planet's natural cooling systems are already beginning to fail. In forests like Germany's Harz Mountains, rising temperatures and decreased rainfall have weakened trees, allowing heat-loving pests like the bark beetle to kill off entire ecosystems. Vital carbon sinks like the Amazon are also struggling. Instead of absorbing CO2, drying sections of the rainforest are now burning, releasing their stored carbon and further accelerating the warming loop. Because these ecosystems are shifting in decades rather than millennia, modern mammals are running out of time to adapt through gradual evolution. The speed of today's environmental shift is already forcing desperate interventions. In Australia, scientists are physically relocating mountain pygmy possums to new habitats, trying to manually stay ahead of a climate that is moving faster than the animals can evolve. The PETM fossil record offers a specific warning. Without a reduction in carbon emissions, the natural world will be forced into a state of nutrient collapse. Earth's history shows that life will persist in a hothouse world. However, the mammals of our future, including humans, may look significantly and perhaps unrecognizably smaller than they do today.